Okay, hello everyone. This is team name M7.2, and we have a three member. This is Ahu, and we have Christina, and unfortunately, Paula couldn't join us today. Our topic was about using deep learning of one-dimensional full waveform immersion, and we tried to perform our best by the help of Joe Vantassel. And here is our um, song for the group coming from the Carole King.
I feel the earth move under my feet. I feel the sky tumbling down. I feel my heart start to trembling whenever you're around.
Okay, would you please, Christina, thank you. So let's look at our objectives and project plan. The main objective of this project is to explore the use of deep learning as an alternative to traditional full waveform inversion for the case of one-dimensional elastic material. Uh, uh, our steps was to implement an acoustic wave equation using a 1D finite difference method. Then we tried to develop a data set of 1D models and waveforms for the use of CNN training. And the part that we spent our time on was to design and train the network for the CNN for predicting engineering material properties for our acoustic waveform equation. And to network and training was the last step. The level of programming difficulty was intermediate, but none of our members were too familiar with the 1D convolutional network project, but we tried our best and we used the skills that offered us by DesignSafe part. So would you please, Christina, thank you. And here is our schedule. We had 4 check-in, and between these check-ins, we have been working hard and spending most of time with the neural network setup with the help of our mentor also. And at the end of the course, we prepared our presentation. As a group, we enjoyed a lot with this project. It was a complete teamwork. We all worked, 3 of us together during this project, and we tried to tune the hyperparameters to create a sample script, and we picked the best model to continue to improve. We started with the DesignSafe in the Jupyter notebook, but while we are using the Frontera, we recognized that we couldn't able to finish our project with Frontera because of it didn't supporting the HDF5 data format. So we switched to the Colab.
So this is our sample network configuration. We had some trial and errors to come up with the final network, our final script. We started with 6 layers of one-dimensional convolutional neural networks. But in the end, we ended up keeping 5 of them to improve and work on the script. We started with 32 filters. Then based on advice given to us by our mentor, we decided to maybe have a gradual increase with the first one being 16 and the last one being 512. Then we had 3 kernel size, our kernel size was 3, our activation was ReLU, Our final design had 3 layers of max pooling, with the pool size being 2, 6 layers of batch normalization, 1 flattened layer, 1 dense layer. Initially, our unit was 100, then we increased to 220. We had 1 layer dropout, 1 resized layer, 2 reshape layers. Then our hyperparameters, which we sort of played around with to see what worked best for us. There was no real method to what our numbers were. They were just sort of what was the sampled script, and we improved based on what we were seeing. The learning rate was set at 0.001, batch size was 400, 10 epochs, atom optimizer, and we used the mean squared error for our loss. And in the end, we ended up normalizing the mean and standard deviation. So the tuning and training of the hyperparameters, our first result was this slide that you're seeing, which we were very satisfied with, but we thought we could do better, which goes back to the previous slide where we changed a couple numbers here and there. Then we ended up getting something that looked like this, which obviously is not the best result. And compared to the first slide, we decided, wow, well, something is wrong with our hyperparameters because we can't go from this to something like that looks like that. And in the end, what ended up happening was, as we played around and tuned our hyperparameters, we ran out of time to make more improvements. But in the end, this was the result that we ended up with for the hyperparameters that were presented previously. And this brought us to the end. And as aforementioned, we did not have a lot of knowledge with CNN work. So our team did our best, and what we ended up with could have been a lot better given more time. Thank you.
Thank you.